Hello everyone, welcome back to my channel. Today I'll be solving one coding problem on linked list from Leetcode. This video is going to be a part of our competitive programming series. In this video we will learn how to approach a problem with a naive solution and then how we can optimize our solution. And we will also see a demo code for this particular problem in both C++ and Java programming language. And if you're new to this channel and you're interested in competitive programming, do check out our competitive programming playlist from the link in the description or from the I button at the right top corner. The idea of this competitive programming series is to learn how to approach a coding problem. So as you can see, I'm on a Leetcode website. I'll go through this problem. So here is the description. Given the head of the linked list, remove the init node from the end of the list and return its head. So for example, let's say if this is the linked list given to you and it has 5 nodes, 1, 2, 3, 4, 5. And here if the value of n is 2, that means you have to remove the second last node, which is this 4, right? And after removing this, your resultant linked list would be 1, 2, 3, 4, right? So as you can see here in the output, if you are given this linked list 1, 2, 3, 4, 5 and the value of n is 2, then the resultant linked list you need to return is 1, 2, 3, 5. Similarly, in the next example, if you are given a linked list with only one node and it is given that n equal to 1, then you will be returning a empty linked list. Okay, so I hope the question is very clear. Another follow-up thing is, could you do this in one pass? So we'll come to this later. First, we'll see how we can approach this problem in a naive way and we'll see the time complexity for it, and then we'll see how we can optimize it, right? So to understand that, I'll go to the presentation mode. So here, for example, let's say you are given this linked list with 5 nodes and we are asked to remove the nth node from end of the linked list. Okay, so this will be your head, okay, using which you'll be able to access your linked list. Now let's say you are asked to remove the 4th node from the end. So here for us, for this given linked list, the 4th node from the end would be, this is the first one, second, third and fourth. That means this node with value 2 needs to be removed and we need to return 1, 3, 4, 5 as a resultant linked list, right? So for that, the naive approach would be to get the length of this linked list first. So for that, I'll simply take a temporary node and will assign the head to that particular node. So now we have another node temp, which is pointing to the head, okay? And then we can simply iterate over this linked list, right? To get the count of nodes, or you can say the length of the linked list. So we can take the initial count as 1 because we are standing at the first node, and then we can start iterating over this linked list. So in second iteration, the temp will be pointing to the second node, will increment the count by 1, it becomes 2. Then similarly, it will become 3, 4, 5. And here, as we have reached the end of the linked list, we can say that the length of this linked list is 5. Now, once we have this length, we can simply calculate one value, which we will call as counter. So we'll simply do n minus capital N. So here n is your, small n is your length of the linked list and the capital N is the nth node which you want to delete. So here it will be 5 minus 4 equal to 1. So using this counter value, I simply need to iterate over this linked list again until we reach the counter value. So why this counter value is required? So for example, let's say if you want to remove this node with value 4. So how do we usually do it? We simply change the previous pointer to point to the next node, right? So similarly, using this counter, we will be able to get hold of the previous node of a node which needs to be deleted. So let's say for example here, we want to delete this node with value 2. That means we want to get hold of this particular node, right? So here you know that you need to iterate over this linked list till you reach the counter value 1. So for that, I'll take another temporary node, I'll call it temp1, and which will be pointing to the head node, and the initial count would be 1. So now as we can see that this count is already 1 and the counter value is already 1. So we don't need to go further. So we'll stay here. So this simply tells you that this is the node whose links needs to be changed, right? Because we want to delete this particular node with the value 2. So here what we can do is we can simply store this particular node. Okay, so here what I'm doing node equal to temp1 next. That means temp1 next is this one. So I'm storing this node in a temporary variable, and then I'm changing the link of this node, temp1 node, to point to the temp1 next. So temp1 next is this one, and then next is this link, right? So I'm assigning this link to this particular node. So that means temp1 next will start pointing to the node with the value 3. Okay, so it will look something like this. So now this node is redundant, and now this pointer is started pointing to this node. So now to delete the node, you can simply use a delete function of C++ to delete the node, and also in Java you can simply assign a null to free that particular memory, right? So in this way you will be able to delete this particular node. So from here, if you return the head or temp1, you will have your desired linked list, right? So I hope this is clear to you. Let's talk about the edge case over here. So here, what could be the edge case? Edge case is when your capital N is equal to the length of your linked list. So let's say you are asked to delete the first node. So for here, if you see the length of this linked list is 5, and if we ask to delete the 5th node from the end of the linked list, that means that will be your first node in the linked list. So in that case, you simply need to check if your capital N is equal to small n. Then what you can do, you can simply assign this head to a temporary node, and then you can simply change the head to point to the head next, right? So that means your head becomes the node with the value 2. Now you can simply delete the temporary node and you can return your head. So in that way, you will be able to handle the edge case also. Now from here, if we try to calculate the time complexity for this problem, you will see that first we iterate over this linked list to get the length of this linked list. So once you have the length of the linked list, what we are doing is we are simply calculating the counter value so that we can iterate again over this linked list to get the hold of the previous node of the node which needs to be deleted. And then from there, we are changing the link, right? So let's say in the worst case, if you are asked to remove the first node from the end, so in that case, you need to again iterate up to the second last node at least to get the hold of the previous node. So in that case also, you are traversing the linked list. So there also you will have a time complexity of order of n. So in total, we can say that we have a time complexity of order of 2n, and also the space complexity would be order of 1 as we are not using any extra space. Now we'll see how we can optimize this solution. Now if you give this solution to your interviewer, obviously he will not be happy with this time complexity of 2n. So he will further ask you to optimize the solution. So for an optimal solution, what we can do is we can start thinking if we can use multiple pointers, because in general, whenever you get such problems, there is a possibility that you can solve this using multiple pointers. So here for this problem, we will be using multiple pointers. So here what we can do is, so first I'll create a temporary node and will assign the head node to it. So my temporary node will start pointing to the head node, and then I'll take other 2 pointers. I'll call it fast and slow pointers. I will initialize these 2 pointers with the temp node. Okay, and then for example, let's say we are given n as 4. That means we need to remove the node with the value 2. So from here, what we have a temp node which is pointing to the head node, and then we have fast and slow pointers which is being assigned by temp node, right? So from here, what next we need to do is we need to move this fast pointer until the value of n. So for us, the value of n is 4. So I'll simply move this pointer 4 times, right? So now at iteration 4, the fast pointer is pointing to the node with the value 4. And after this step, what we need to do is we need to move both slow and fast pointer by 1 step until the fast pointer reaches the last node. Here our slow pointer is at temp node and fast pointer is pointing to the node with the value 4. Now after 1 step, we will have slow pointer at the first node and fast pointer at the last node. Now from here, we can simply notice that slow pointer is pointing to a node which is a previous node of the node which needs to be deleted, right? So from here, what we generally need to do is we simply need to remove this node and change the link of this node to point to the node with value 3, right? So now from here, to change this link to point to the node with value 3, we simply need to do slow next equal to slow next. So what is slow next? So slow next, if you see, slow next is this and slow next is the node with value 3. So we are simply taking this link and assigning it here. So that means now your slow next will start pointing to this node instead of the second node, right? And from here, you can simply return your temporary next, which is pointing to the head node. So if you return this, that means we are returning a linked list with value 1, 3, 4, 5, which is our desired linked list, right? So now from here, we will again talk about the edge case. So the edge case was that if your capital N is equal to small n, That means if n is fifth node, so if you are asked to remove the fifth node from n, that means it will be your first node. So in that case, we'll see how this previous process works. So here, so initial state was something like this, where we have this temp node pointing to the head, and then we have fast and slow pointer assigned with temp. So the first step was to move this fast pointer until the value of n. So here n is equal to 5. That means we need to move fast pointer by 5 steps, and after that it will look something like this, right? And from here, the other step we performed in the previous process was we will again move the fast and slow pointer simultaneously till this fast pointer reaches the last node. But here, if you notice, this fast pointer is already at the last node. That means that step will not get executed. And after this, we know that this slow pointer is pointing to the node which is previous to the node which needs to be deleted. So here, if you notice, this slow pointer is nothing but your node which was assigned by temp at the beginning. That means slow pointer is currently pointing to the first node. So now from here, we simply need to change the link of this slow pointer to point to the second node. So for that, we need to remove this first node, and to do that, we simply need to change the link of this slow pointer to start pointing to the second node. So for that, what we did in the last process, we will repeat the same. We'll simply do slow next equal to slow next next. So here slow next is the node with value 2. So now slow next will start pointing to the value 2, and with this operation our temp next link will also be updated, right? Because if you remember, this slow pointer is nothing but your temp node, right? Because at the beginning we assigned this temp node to this pointer. That means this link will be deleted and you will have a updated link which will start pointing to the node with value 2. So I hope this is clear. I'll repeat this part again. So how this link get updated is, so at the beginning, if you remember, I'll show you. We have done something like this, where we have initialized 2 pointers with temp, right? So at this point, so when you update slow next, the temp next will also get updated, because what we did earlier was we assigned temp to this pointer, slow pointer, right? That means now slow and temp are pointing to the same memory allocation, right? That means we are referring to a same object. So when you update slow next with slow next next, your temp next will also get updated to slow next next, which is the node with value 2. So from here you will simply return temp next, which will be pointing to the node with value 2. That means you are returning from 2 to 5, which is your desired linked list. So if you have any confusion at this part, let's go through the code. That will become clear. So from here, if you try to evaluate the time complexity, you will notice that we have done the entire process in only one pass, right? We simply move the fast and slow pointer once and we get our desired linked list. That means here the time complexity is order of n and the space complexity is order of 1, as we are not using any extra space. So yeah, now is the time to see some demo code. I'll show you both C++ and Java code. So let's jump to the Leetcode editor. So for that, I'll go to the Leetcode website again. So here I have already written this code snippet. So I'll go through this. I'll explain what we are doing. This is the Java code for the given problem. If you want to see the C++ code, you directly jump to the mentioned timestamp for that. So let's go through this first. So here we can see that we have this method remove nth from end. Here we have head of the linked list and the value n, which needs to be deleted. So here what we did is, first we created a temp node and then we make this temp node to start pointing to the head, right? By updating temp.next equal to head. And then we created 2 other pointers, fast and slow, and we assigned temp to both of these pointers, right? So as I have already shown in the presentation, that the first thing we do is we simply move the fast pointer until the value of n. So we are iterating from 1 to n, and then we are moving this fast pointer by doing fast equal to fast.next, right? And once we complete this, what we do is we simply move fast and slow pointer simultaneously by one step until the fast pointer reaches the last node of the linked list. So here we are doing a check fast.next not equal to null. That means we will perform this operation until this is a last node. Okay, so in that case we will simply move both fast and slow pointer by doing fast.next and slow.next, and once we reach the last node, we'll simply need to update the slow next, right? Because as I mentioned, once you complete this process, you will have a slow pointer pointing to the previous node for the node which needs to be deleted, right? So from there I can simply change the slow.next to slow next, right? And from here we can simply return the temp next. So yeah, I hope this code is clear. If you have any confusion, I would recommend you to watch this video again, and this will surely make sense to you. Now I'll talk about the edge case we discussed on the presentation, right? Where we said that if we need to delete the first node, then in that case this fast pointer will reach to the last node, right? And this block will never execute it. And in that case, I mentioned that if you execute this line, your temp node will also get updated, right? Because if you see, the first thing we are doing here is we are assigning the slow pointer and the fast pointer with temp node, right? And temp node is pointing to the head. In that case, this slow pointer and temp pointer is pointing to the same memory allocation. And as this block is not executed, this slow pointer will never get updated, right? So in that case, if you perform this line, your temp node will also get updated. That means your head will be changed in the edge case scenario, and when you will be returning the temp next, it will be your second node. So I hope this is clear. If you have any confusion, I would highly recommend you to watch the video again. It will definitely get clear. Okay. So now is the time to see the code for C++. So I'll simply change the language. Here I've already written the code. It is very much similar to the one in Java. So here if you see, we have this function which has head, okay, and then this value n which needs to be deleted. So the first thing we are doing is we are creating a temp pointer, and then we are making this temp to point to the head node, right, by doing temp next equal to head. So now your temp pointer is pointing to the head node, and then we are creating two other pointers, slow and fast, and we are assigning with the temp node. And then the first thing we will be doing is we will simply move the fast pointer until the value of n, and then the next thing we do is we simply move both fast and slow pointer until the fast pointer reaches the last node. That means here if you see, we are doing a check fast next not equal to null. That means if it is not the last node, keep moving your slow and fast pointer by one step. And once we reach the last node, we simply update the slow pointer, right? Because we know that slow is now pointing to the node which is previous to the node which needs to be deleted. That means your slow next will start pointing to slow next, right? And then we can simply return temp next, which will be pointing to the starting of your linked list. So I hope that is clear. I'll also talk about the edge case where we need to remove the first node of the linked list. That means in that case, this loop will get executed and your fast will reach to the last node, right? In that case, your while loop will never get executed. That means fast next is already pointing to null. So here directly we are doing is we are updating the slow next. So if you see, if this block does not get updated, the slow pointer will always be pointing to the temp, right? Because here what we did is we assign slow with temp. That means your slow pointer and temp pointer are pointing to the same memory location. That means if you update the slow pointer, your temp pointer will also get updated, which I mentioned in the presentation. That is the reason when you return temp next, it will be pointing to your second node, right? And which is your desired linked list. So I hope this is clear. If you have any confusion, I would highly recommend you to watch the video again, and I assure you that you will definitely understand it better. That's all about this video. If you learned something from this video, please hit the like button. And if you're new to this channel, please don't forget to hit the subscribe button and press that bell icon so that you get notified for our upcoming new videos. Thank you for watching.